Exercise 6D, graphs of sine and cos. Today we are learning about the graphs of sine and cos. What you need to be able to do is find the amplitude and the period of sine and cos graphs, find the x-intercepts of these graphs, and then go ahead and sketch them. Last year you learned by plotting what the graphs of sine x and cos x are. So we're just going to very briefly talk about them, but the idea is that x is going to be our angle and y is our corresponding value. So sine of 0 is 0, sine of pi on 2 is 1, sine of pi is 0, sine of 3 pi on 2 is -1, and sine of 2 pi is 0. So that gives us our basic shape, and of course then we can extrapolate that for wider domains. So that's the graph of sine. Similarly, the graph of cos, cos of 0 is 1, and things like cos of pi is -1, cos of pi on 2 is 0, and again that's where we get our graph of cos, and that's where we extrapolate our graph from. So in general, just a couple of properties about these. The graphs repeat themselves after an interval of 2 pi units. It makes sense because with the unit circle takes 2 pi until we get back to our angles. Because it repeats itself, we call it a periodic function. Oh, that highlighted really weird. We call it a periodic function, and therefore the length that it takes to repeat is called the period of the function. The maximum and the minimum values of these graphs are 1 and -1 because when you think about your unit circle, the radius is 1. And the distance between the mean position, as in the middle, to the top or the bottom, so the maximum or minimum, is what we call the amplitude. So remember, amplitude is a distance, that's why it can't ever be negative. So in terms of how we go about sketching it, we need to find the period. The period is 2 pi on n. So now that we've done transformations, hopefully you recognize that that's a dilation of 2 pi on n units from the x-axis. So we always put it 1 on, and then of course we multiply by a period that we've already got, which is 2 pi, and amplitude is a. These signs just mean modulus, which means it's going to always be positive. You always take the positive value of it. So as an example, this is what 2 sine x equals. The period of this is just 2 pi, and the value in front of x is 1. That's why it's just 2 pi divided by 1, which is 2 pi. So you can see that the length of this whole thing goes till 2 pi, and the amplitude is the value at the front 2. That means the height is going to be at 2, and the minimum is also going to be at -2. A cos graph, this is cos 2x. The amplitude that you can see is just 1, which is why the maximum minimum heights are at 1, -1. But this time the period is different. This time our dilation factor is 2. So our period is going to be 2 pi divided by 2, which means that's going to be pi. So when we get up to pi, that's 1 cycle there. It's pretty straightforward to be able to find the x-intercept because once you draw your 1 cycle, what we can then do is divide everything in quarters. So I usually just divide that by half, divide it again by a half, and then I know I'm going up by pi on 4. Now, in your notes, for some reason, you don't have an example. So what I'm going to do is I'm going to just go through an example from the textbook just to be able to make sure that you all understand how to do this. So question 7 says, sketch the graph of this, 5x equals 5 cos 3x between 0 and pi. So the first thing we want to do is we want to find out what the period is. The period is going to be 2 pi on n, which in this case is 3. So it's going to go for 2 pi on 3 for 1 cycle. In general, what you can think about is that between 0 and 2 pi, the number of cycles that we have is this value here. So we're going to usually have 3 cycles. Now, of course, this isn't between 0 and 2 pi. So in this case, because it's half of it, we're probably going to expect 1.5 cycles of cos. The next thing that we have is the amplitude. The amplitude in this case is 5, and it's a cos graph, which means it's going to start at the top. So that's pretty much all the information that we need. We're going to go ahead and sketch it now. So this is 1 cycle. That's 2 pi on 3. And then I'm going to continue until I hit pi. But just so that I can make sure I'm hitting the right value, I'm just going to find all the other x values as well. So first thing I'm going to do is divide it by half. So half of 2 pi on 3 is just 1 pi on 3. And then half of that again is pi on 6. So what I can see is I'm going up by pi's on 6. So that's pi on 6, pi on 6. Obviously my scale is way off, sorry. Pi on 3 plus another pi on 6 is going to be, well, this is 1 pi on 6. This is 2 pi on, sorry, 1 pi on 6, this is 2 pi on 6, this will be 3 pi on 6 or pi on 2. And then we have 2 pi on 3. So for my other values, I can continue adding. So an easy way to think about it is that's 1, 2, 3. This will be 4 pi on 6. So this will be 5 pi on 6. That means 6 pi on 6 is 1 pi. So in fact, I'm going to end here. So as expected, that's 1.5 cycles. This is 6 pi on 6 or just pi. So what did we say that was for? This will be 5 pi on 6. So hopefully you understood that way of counting. You don't have to do it that way, but that's what I find easiest. Once I find my first value, my first quarter, it's always just going up by 1. So 1 pi on 6, 2 pi on 6, which applies to pi on 3, 3 pi on 6, 4 pi on 6, 5 pi on 6, and 6 pi on 6. And I just use that to be able to give me my reference of pi. My highest value is 5, my minimum value is -5, and everything else that is required is labeled. And that's how you would go about sketching these graphs.